Okay, let's look at a small problem on the application of heights and distances. The question goes like this. A circus artist is climbing a 20-meter long rope which is tightly stretched and tied from the top of a vertical pole to the ground. Let's read it half. So, I'll draw. Let this be the pole. A rope is tied. Okay. Find the height of the pole if the angle made by the rope with the ground level is 30 degree. Okay. Let this be the rope. Okay. Let this be the rope, and the circus artist is climbing this rope to reach the top of the vertical pole. So, he gave one important thing. The angle made by the rope with the ground level is 30 degree. So, this angle is 30 degrees. And the length of the rope is 20 meters. Because he has given is climbing a rope 20-meter long. Okay. So, we need to find the height of this pole. Let the height of this pole be h. Now, this will be a right angle triangle. Obviously, because this angle will be 90 degree. So, the application here will be, we know the hypotenuse, we need to know the height. How? Sin theta is opposite side by hypotenuse. So, here sin 30 degree, theta is 30 degree, that is the angle of elevation. So, sin 30 degree is equal to, opposite side is nothing but this height which we need to find. So, sin 30 degree is opposite side h by hypotenuse length 20. So, sin 30 degree into 20 is equal to h. What is sin 30 degree? Sin 30 degree, as we learned from tables, it is 1 by 2 into 20 is equal to h. So, 2 tens. So, h is equal to 10 meters. Height of the pole is h and it is equal to 10 meters. Okay, this is the way we solve a simple trigonometric problem related to heights and distances. Now, let us look at another problem. It is a 1.5 meter tall boy is standing at some distance from a 30 meter tall building. The angle of elevation from his eyes to the top of the building increases from 30 degree to 60 degree as he walks towards the building. Find the distance he walked towards the building. So, what happened? Initially, the boy was looking at the top of the building with an angle of inclination or angle of elevation 30 degree. What happened? As he moves towards the building, the angle of elevation increases. How? If the person watches the top of a building, pole or anything with an angle of elevation theta, then if the person moves towards the building, then the angle of elevation will increase. That is, here in the first case, if it is at some x distance from the building, the angle of elevation, if it is theta, then if he moves towards the building, then the angle of elevation here will be more than theta. Look at here, a 1.5 meter tall boy is standing at some distance from a 30 meter tall building. So, this is a 30 meter tall building. So, the boy height is 1.5 meter. So, the angle of elevation from his eyes to the top of the building increases from 30 degree to 60 degree as he walks towards the building. Initially, the angle of elevation is 30 degrees. Let this be the boy and this be the height. So from his eyes to the top of the building, it is 30 degree. This be the distance from the building to the boy. So what is happening? This boy moves towards the building. That means he is walking towards the building, and the angle of elevation from his eyes to the top of the building increases to 60 degree. Okay, so he says find the distance he walks towards the building. He is asking about from here to here this distance. What shall we do? So we know that this distance is 28.5. How? This whole distance is 30 meters. In that, the boy's height should be subtracted. So what I am going to do? 30 meter minus this 1.5 gives this height. So this will be 28.5. Okay, so in order to not to get confused, let's mark this A, B, C, T. So AB is equal to 28.5 meters. And EF is the distance from building to the boy. But before writing EF is equal to DB. The distance from building to his feet will be equal to the distance from building to his head. Let us assume that he is standing straight. So EF is equal to DB, distance from the building. So EF is equal to DB is equal to distance from the building initially, and let this be X. So I am talking about this whole distance as X. So what should I do? I'll take tan 30 degree. Tan 30 degree will be AB, opposite side by adjacent side. Adjacent side is DB. We know the value of AB, it is 28.5 meters. And what is tan 30? Tan 30 is 1 by root 3. So, which implies 1 by root 3 is equal to 1 by root 3 is equal to AB is 28.5 meters by DB, which implies DB, which is equal to X. DB I took it as X. So X is equal to this root 3 into 28.5. So 28.5 into root 3. Let here DC be the distance he walked. What is asked in the question? Find the distance he walked towards the building. He asked this distance, this DC, from here to here he walked, after which the angle of elevation changed to 60 degree. So what shall we do? I'll do one thing. I'll write tan 60 degree, which is equal to, again tan 60 is AB. I'm writing it here, ABC 60 degree. Tan 60 degree, and this is 90, we all know. So tan 60 degree will be AB by opposite side by adjacent side, BC, which implies BC is equal to, what is AB? 28.5 tan 60, which implies BC is equal to 28.5 divided by root 3. Tan 60 degrees root 3. So, if I subtract from x this BC value, that is DB minus BC is equal to DC, distance he walked. So we want DC, which is the distance he walked. How did we get DC? Out of this DB, that is distance from building to the boy's eyes, I have subtracted BC. Then I'll get DC. So I got DB, which is x, which is equal to 28.5 into root 3, and I got BC, which is 28.5 by root 3. So DC is equal to DB minus BC, which is equal to 28.5 into root 3 minus 28.5 by root 3. So, if I take the LCM, it is root 3. So, 28.5 root 3 into root 3 will be 28.5 into 3. How did we get the 3 here? We are multiplying root 3 with root 3 after taking LCM. Then we'll get 28.5 into 3 minus 28.5. So if we solve it, we'll get 57 by root 3. Now I'll multiply this as root 3 on numerator and root 3 on denominator. I'm just rationalizing it. So I'll be having DC is equal to 57 into root 3 by this root 3 into root 3 is 3. So 19s, I'll have 19 root 3. So the distance he walks towards the building will be 19 root 3. So initially the boy had an angle of elevation of 30 degree. Then after moving towards the building, the angle of elevation increased to 60 degree. So what is the final value of DC? DC's final value is 19 root 3.
If you like the video, please hit the like button, comment and share it with your friends. Also don't forget to subscribe for all our future videos.